On quadratics, we in the past have talked about 3 different forms. You see one form right here. This is the form that you frequently see a quadratic in. We call this one standard form. Once you see standard form, the only issue with it is that it doesn't really tell you much about how to graph that quadratic. The main thing that you need in order to graph a quadratic is the vertex of it, which is your maximum or minimum point of what we call a parabola. Now, the only thing the vertex or the standard form really tells you is to know whether it opens up or down, and that's always with that a value in front of the x squared. But that is the nice thing about all the forms, is that all of them have an a value, and they all tell you the same thing, whether it opens up or down. So the very basic part of this, the vertex for this quadratic, would be the point 1, -2, and we would call that a minimum because it is the bottom of the U shape. I'm not going to spend too much time on this. This is the vertex of that one. That's the point -2 up 4. And that would be a maximum. You remember that kind of stuff? Yeah. All right. So some key features that we talk about with them, you do need to know whether they open up or down based off of the equation. And you do need to know a little bit more about them. We're going to talk about the width, but we're just going to use that in general graphing. We're not going to do a whole lot of specifics with it. So the first thing you need to know is direction of opening. When a is greater than 0, the parabola opens up. When a is less than 0, it opens down. Now that notation, for some of us, we have to actually think about what that means. When a is greater than 0, what kind of number is a? Positive. So when a is a positive number, it opens up. When a is less than 0, what kind of number is that? Negative. It opens down. A also tells us about the width. Every quadratic starts as y equals x squared. That's what we call the parent function. And every parabola in its most basic form here has a number of 1 as its a value. So if a is actually 1 or -1, it's going to be the same width as we're used to, which we'll talk about in a minute. If a is a number less than 1, and notice it says absolute value of a. I don't worry so much about the absolute value. You just have to think if a is any positive or negative number that's like a fraction, 1/4, 1/2, 1/3, that kind of stuff, it's going to be wider. So it typically does the exact opposite of what you want to think it does. When a is a number larger than 1, 2, 3, 4, or -2, -3, -4, bigger numbers like that, it is narrower, which doesn't, for some reason, ever fit in that blank. Really, the way they taught you how to graph these before was using the slope almost of that to get the first point on either side, and we'll practice that just in a second. Now, we are not going to be doing the vertex or the axis of symmetry. I do want you to know that the solutions to these are the x-intercepts. So if you are ever asked to solve a quadratic by graphing, that simply means to graph it and see where it crosses the x-axis. Now, to be completely fair, as someone who teaches pre-calc and plans for calculus for you guys, there are very few times that I'd want you to actually graph one of these to solve it. There are so many other better ways for that. Because if it doesn't cross in a specific point like 5 or 1, then you're just taking a guess. You have no idea what it actually is. It could be 5.5, and you don't even know. Your graph might be off. My drawing is horrendous. So you might never know where it crosses. The only reason you would actually, on like a calculus test, solve one of these by graphing is if it very specifically crosses on the x-axis at like a whole number, or they've given you a graph and that's all they've given you. We have so many other ways to solve. We have factoring, quadratic formula, completing the square, square roots, and we're going to talk about all of those over the next week. But graphing, just know that the x-intercepts are considered the solutions. Okay? On the back of this, real quick, we're going to practice graphing some. At the beginning, we're just going to talk about direction of opening and whether it would be wider or narrower. maxes and mins, just kind of knowing stuff about the function from the equation. Then we're going to talk about how to graph them. I am going to skip the standard graphing and come back to it because vertex form will help us the most. So first and foremost, if I just gave you an equation, you should be able to look at this, identify your A value right here, and that should tell you a couple things. In number 5, the fact that the A value is positive 3 tells me that this opens which way? Up, which automatically makes your vertex a what? Minimum. Okay, if you literally have to picture the U facing up to think that the minimum would be the vertex on that, that's fine. Because it's the number 3, which is larger than 1, or negative 1 in that either case, is it going to be wider or narrower? Narrower. On the other hand, number 6 has an A value that is what sign? Positive or negative? Negative, which means it opens which way? Down, making my vertex a max. Now, before you answer wider or narrower on number 6, be very careful. That is a fraction, but is that fraction bigger or smaller than 1? Bigger than 1. It's outside of 1 or negative 1. That means it's still going to be narrower, even though it's not going to be much narrower. Okay. Any issues with those things? 7 opens up or down? Up, making our vertex a minimum, wider or narrower? First one that's wider. And last but not least on this, number 8 opens up or down? Down, making my vertex a max. And this one has a decimal, but still, can we tell that decimal is larger or smaller than 1? Yes, smaller than 1 makes it wider. Now we're going to talk very basically about how to graph these things on actually the next page over. Let me see what page this is. Told you I'm skipping around. On page 76 is where I want to start. 76, number 13. For the sake of simplicity, we are going to make everything vertex form, which means we're going to learn how to complete the square if you don't know it yet. Let me find the right page. I keep flipping around. All right. Vertex form is the most useful form because it has the vertex directly in the form. It's also the most useful because it involves transformations, which we're going to talk about next unit, and you'll get a good idea of this. The H value in here tells you the left-right shift. And the K value tells you the up or down shift. The vertex can be pulled directly out of the equation. It is that letter H and K inside the equation itself. Notice, though, in the formula, the H has what sign in front of it? A negative. That means when you pull the H out, it's going to be the opposite of what it looks like. So for question 13, what's going to be my vertex? -1, -2. You only change the sign of the one in the parentheses because that negative that was already in the equation makes it the opposite sign. The axis of symmetry does go right down that middle of it, which is at H. But just like the other ones, if A is negative, it opens down, and if A is positive, it opens up. So that A value still tells me the same thing. So on something like 13, I start by graphing my vertex. -1, -2. If you want to draw, you can't hardly see that, can you? If you want to draw the axis of symmetry down the middle, you're welcome to do that. We draw that as a dotted vertical line. All that tells us is that our quadratic is the same on either side. And from talking to the Algebra 2 teachers, you were mostly taught to use the slope of the A. In 13, what is my A value? 1. So that basically means to get a point on either side, I go up 1, right 1 from my vertex, and I go up 1, left 1 from my vertex. How do I know it goes up? Because my A value is positive. And that is enough to kind of give me my basic shape of my quadratic. Do we vaguely remember this? Yeah or no? Kind of. All right. We'll try that again with 14. But we're going to turn everything into this form so that graphing is the same thing again and again and again and again. All right? On 14, first we identify our vertex. What would it be in 14? 1, 5. Good. Our A value tells us this one is going to open which way? Down. So I kind of have that in my head already. Start with my vertex 1, 5. If you want to draw your axis of symmetry down the middle, you can. Really, you don't hardly see anyone do that outside of Algebra 2, which is why we just kind of stop it. The A value also tells you the slope of it, and it's supposed to be wider. Okay, so you use the down 1 over 3 from either side on the vertex. Again, we know it's down because my A value is what? Negative. So I go down 1 right 3, I go down 1 left 3, and that kind of gives me the basic idea of how wide my parabola is. The graphing part should be pretty easy. Yeah? All right. Now the main thing we're going to do today is practice completing the square to turn the other forms into this form, because the graphing is easy. It's the turning it into this form if it's not in this form. This is a frequently used form. We do transformations a lot, and it's kind of the most logical form to use. But on the SATs, the ACTs, they might not give this to you. They give you a different form, and you might not know how to graph it. However, remember, on those kind of tests, what do you always have? Calculator? Graph those on your calculator sometimes. That might help you. If we don't know how to graph those on your calculator and find the x-intercepts on your graph, please let me know. I'm happy to help you do that. If you would flip back a page or so, we're going to practice graphing standard form and changing these into... So back to page 72. Is that right? I could be lying. No, I have no idea what page I'm on. All right. On something like 9. 9, you need to be able to take this. It's in standard form. We know it's not in vertex form because why? What's missing from this formula in number 9? The parentheses with the squared on the outside. I do have a squared in the problem, which tells me it's a quadratic, but I don't have parentheses. All right, so completing the square to turn this into vertex form. This is the part you really need to follow along, because if you can't follow the process, you'll struggle with this. All right, so for vertex form, you keep your first 2 terms on the left, and you move your C term to kind of an imaginary opposite side on the right. You really don't need that f of x that's out front. That's just saying y equals, so we kind of just move things around. All right. From here, we are going to fill this blank right here so that we can force this to factor. Before you can do that, it's best, I'm trying to decide whether it's best to divide or factor out the -1. It depends on how you were taught before. Let's go with, if I divide, was that going to change it? Yes. All right, factor it out. Anytime you have a number in front of the x squared, you want to factor it out. So in this case, what's the number in front of my x squared? -1. So I'm just going to factor it out and leave it out here. It's going to change my x squared, make it positive. It's also going to change my 2x and make it what? Negative. I still have this lovely blank over here. In order to fill that blank properly, and this is what you always do for this type of thing, you take the middle number here, you divide that number by 2, and you square it. Always. B divided by 2 squared. That's always what you're doing. In this case, when I take -2 divided by -2, what do I get? -1. When I square it, what am I getting here? +1. That is what I'm putting in this blank right here. Any issues with that? You don't always have to show all that work, but I will tell you why in just a second that I did. Now here's the trick. If we do something to one side of the equation, we also have to do it to The other side. Be careful. What did I actually do there? Did I add one? No. I actually subtracted one. Why are we saying that I actually subtracted one? Because if I actually factored in that -1 and multiplied it back in, it's actually going to be a -1. That is what I'm actually going to do to the other side. That is the hardest part of this entire thing, remembering that. If there's a number out front, you're actually going to be adding whatever that number is times that. And we'll practice this multiple times. This is where we're kind of camping for the rest of the day. Okay, so here's what I have. I have -1 outside. I have x squared minus 2x plus 1 inside. And on the other side, I have -4. We are almost done. Someone tell me, what does x squared minus 2x plus 1 factor into? X minus 1, which we want to write as x minus 1 squared, so it looks like vertex form. The last thing that you do in order to make this vertex form is move that 4 back over to the left. So my vertex form for this is y equals -x minus 1 squared, and because we moved the 4 back to that side, what do we get? +4. All right. Now, the reason I showed this work right here, what do we notice about this number in conjunction with what we factored over here? When I divide my b by 2 before I square it, that number is always what is going to be in the parentheses right here when I factor. I point that out because sometimes there's going to be fractions and you don't want to factor with fractions. That's going to be our trick to know what it factors into later. Now, if I want to graph this one, first, what's my vertex? 1, 4. Does it open up or down? Down, and my slope is -1 in this case. So 1, 4, over 1, down 1, over 1, down 1 the other way. Draw my quadratic real quick. Now, I know that completing the square business is kind of the hardest thing out of the whole day. But the other good news is we're going to keep using that in this chapter. So it's not just for this, it's for lots of things. But we're going to just practice this like 10 more times. No, I don't know how many times, but that's all we're doing for today. That's it. Done. Okay? All right, on the next page, let's just practice this again. Mostly the completing the square process here. On number 10, I know it's not in vertex form. I know it is in standard form. So I first have to start by completing the square to make this vertex form. How do I start doing that? What's my first step? Move what? Move the c to the right, the 1. If you would like to, in the same step, you may also factor out your greatest common factor on the left or your leading coefficient, which in this case is what? 2. I like to save myself work, so I do that. So that's kind of my first step there. Factor out that leading coefficient and move the c to the right. To fill that blank that we've left for our new c value here, what number do I divide by 2 and square? I take 2, because we've taken out that 2, which leaves that one a 2 in the middle. Divide by 2 and square it, right? What number are we going to put in our blank right here? +1. What have we actually added, though? 2, because if I distributed that 2 in, I'm really adding 2. So that's what I add to the other side. Again, that's the trickiest part of the whole thing. Some people have other ways of doing this where they divide it to the other side, but it gives you a lot of fractions, so I don't bother doing that. In this case, then, we factor. What does x squared plus 2x plus 1 factor into? X plus 1, which is x plus 1 squared. Over here on the right, we now have a +1, and how am I going to move that back to the left? Subtract it. So it goes much quicker the second time. What's my vertex then? -1, -1. This is going to open which way? up, and we're going to use that slope of 2 to graph that. So -1, -1. From that vertex, I'm going to go up 2 over 1, up 2 over 1 on either side of my vertex, which is going to give me the basic shape of my quadratic. Issues? All right. Now, 11's going to be interesting, mainly because of the fraction. We love fractions. Before I ever get started on 11, I need to put it in the right order so that I know what's going on with it. So I'm going to go ahead and put the -1/2 x squared first, the -x second, and the +2 third, and then get started on my completing the square process. First thing I do is move the c to the other side and factor out my a value. So I'm going to subtract 2 over here. What am I factoring out? -1/2. All right. Now, how many of us like to factor out a -1/2 from a -1 in the middle? Factoring is really dividing by that number. So what's the same as dividing by -1/2? Multiplying by -2. So if I multiply this by -2, what's it going to give me? +2x in this case. So that's kind of how you're going to factor when it's a fraction. You're going to multiply by the reciprocal mentally. Now this is going to actually work out the same way as the last one because it's the exact same thing in the parentheses when I factor it out, right? So in this case, I get 2 divided by 2 squared. I'm going to put what number in my blank? +1. What am I really adding or subtracting in this case? -1/2. Because if I distributed this in, that's actually what that is. Right? Now, for the sake of this, we're not going to do, because we're graphing, it's really hard to graph improper fractions mentally. So, when I factor this, again, what's this going to factor into on the left? X + 1 squared. I'm going to just go ahead and leave this right-hand side as -2.5. Because I'll be honest, I don't graph -5/2. I'm a math teacher and I don't graph that. I graph decimals because they're much easier to graph. So my vertex form is going to look like this. What's my vertex going to be? -1 up 2.5. And this is going to open which way? Down, which means I go down 1 over 2. Whoops, that's not a full 1. Down full 1 over 2. Down full 1 over 2. And that's going to be the basic shape of my parabola. Do we feel like we need more graphing practice or just more completing the square? I feel like the graphing's easy. I mean, we're quiet today, but yeah. All right, let's look at 12, and we'll just practice completing the square on that.